Welcome back guys, I hope all of you will be fine. So this is question 2.17 and the statement of this question is consider the circuit shown in figure P2.17. This is a figure. In this figure, part A of it is find V naught using Kirchhoff's laws and Ohm's law. B. Test the solution for V naught by verifying that the total power supplied equals the total power absorbed. Okay, so this is the circuit and here we have to apply the Kirchhoff laws and Ohm's law. So first of all, let us see that what is meant by Ohm's law, what is meant by the Kirchhoff's law. Okay, so let me use this green color for it. So for Ohm's law, we know that according to the Ohm's law, V is directly proportional to I. Okay, in a linear circuit, when you will increase the value of the voltage, which is the independent variable, the value of the current will also increase. Okay, so removing this proportionality sign, it will be V equal to IR, where this R is the constant, and if the resistance is constant, increasing the value of V will also increase the value of I as well. Okay, so this is Ohm's law. Also, by discussing the Kirchhoff's law, we have two very famous laws. The first one is the KVL or Kirchhoff's voltage law. The other one is the KCL, Kirchhoff's current law. Okay, so what is this? According to the KVL, the sum of all the voltage in a loop, in a branch, will also be equal to 0. Okay, or we can also interpret it like that: in a branch, the sum of all the voltage rises will be equal to the all voltage drops. Okay, so suppose we have here this branch. This is what? This is the resistor, this is another resistor, here we have this resistor. Okay, so if there is no voltage here, this is, let me call R1, R2, this is R3. Okay, and if we apply here the voltage source, this is V of S, this is plus, this is minus, so it will be VR1, VR2, and it will be VR3. Okay, so as these are the resistors, which are the passive elements, and it always absorbs the energy, and voltage is dropped across them, so therefore it will be plus minus here, plus minus here, plus minus here. So according to the KVL, here the value of Vs will be equal to VR plus VR2 plus VR3, or ultimately we can also write it like Vs minus VR1 minus VR2 minus VR3. This must be equal to 0. Okay, so this is in the what? This is in this circuit. Suppose here, if we have a branch, okay, if we have a branch like this one, many people confuses here because of it, and this is what? This is the ground one. Okay, so here we have, let me have here VP. This is the, let me call it 1 kilo ohm resistor, and here we have this one negative positive 5 volt. Okay, so we can also apply it here the KVL as well. And what will be the KVL? As this one is the positive terminal, so it can be interpreted like that this is positive and the other terminal here will be negative. Okay, so applying here, what we will get if we consider the direction of the current like this one, so we can see that the current is entering through this negative, coming out of this positive, so it will be VP. Also, this is the voltage dissipating device, so plus minus, so here it will be V1K. Okay, this is the voltage across it, and here again you can see that the current is entering through negative, coming out of this positive, so this is again the V5 is again the voltage drop. Okay, so and this one is what? This one is the ground one, and it is always on 0 volts. So here let me use it 0 volt, and it will be equal to 0. Okay, we can always apply it to branches, to loops, to meshes, and anywhere where do you want. Okay, so this is the KVL. Also in KCL, if you want to interpret that what is KCL, so KCL says that to a node, if this is a node, if the current is moving towards it, let me call it I naught, so it will be equal to the currents which are going away from this node. Okay, so this is I1 and this is I2. Okay, so according to KCL, Kirchhoff's current law, the current moving towards a node in a circuit will always be equal to the sum of all the currents moving away from a node in a circuit. Okay, so here we can see that I naught is equal to the I1 plus I2. Okay, so here we can see that this one is here. So whatever the direction of currents here would be, we have to utilize them here as well. If the currents are moving away, so the sign of them will be positive. If these are coming towards it, it means that these are coming towards them. So therefore, if all the currents are coming towards them, let me have this one, this current is coming towards it, this is also, let me I take it IB, and this is IC. So here it will be I naught plus IB plus IC, this will be equal to 0 because all the currents are moving towards this node, and that's why the summation of all the currents will be equal to 0. Okay, so that is basically the interpretation of the Ohm's law, Kirchhoff's law, KVL, KCL, and all the things which we will be using in this question. Okay, so that's it for today. We have seen that what is mean by Ohm's law, what is mean by the KVL, KCL, and in our next video we will try to apply them in question 2.17. Till then, take care of yourself and I will see you soon.